All right, thank you for the introduction. My name is Brad Schondelmeier, and I'm a fisheries biologist with the Massachusetts Division of Marine Fisheries. Last year, a report was requested characterizing the Longfin Squid fishery in Nantucket Sound and adjacent waters. This report has recently been completed and will be published shortly. So today I'll be walking you through the report, starting with a background on longfin squid as a species and the report itself, a summary of how we selected the data for the report, data analysis we conducted to find the trends and takeaways, and then what those takeaways were and what they told us about the issues expressed regarding the inshore fishery. So the report will be released shortly to the public. We started by considering the biology and ecology of longfin squid. After a thorough literature search, we found that as a species, longfin squid are a resilient animal. They form micro cohorts, which is just multiple groups of different aged spawning and juvenile squid. We found that they are fast growing, maturing in as little as 5 months, and that they also form these inshore, offshore spawning dynamics. The inshore spawning squid in the spring and the summer resulted in the adults offshore, which were harvested. When those adults spawn offshore, the juveniles migrate inshore, forming the biomass that is fished on in the spring and the summer. Ecologically, these are important species as well. They're a predator of plankton, shrimp, worms, whiting, mackerel, herrings, and other small fish. And they're the prey of dolphins, pilot whales, striped bass, bluefish, black sea bass, cod, haddock, et cetera, et cetera. In terms of management of longfin squid, NOAA Fisheries regulates, NOAA Fisheries regulates the harvest, and the Mid-Atlantic Fishery Management Council manages the fishery through the Squid, Mackerel, Butterfish Fisheries Management Plan. In 2018, the current setup of a tiered moratorium permit was established with various trip limits, as you see here. The annual harvest is managed in trimesters, with 17% of the annual quota being available during trimester 2, which is May through August. Quota closures result in 2,500 pound trip limits, and quota rollovers and paybacks are activated within the same fishing year, which is the calendar year. For about a decade, there's been a cap on the amount of butterfish that can be caught within the longfin squid fishery before a 2,500 pound squid limit is enacted. And federally permitted vessels report their catches via vessel trip reports or daily through their vessel monitoring system. For any catches, for any vessels to fish in Massachusetts state waters for longfin squid, they need a DMF coastal access permit with small mesh trawl squid endorsement. There's no daily trip limit for the vessels, and they report their catches monthly. Looking into the effort of this fishery, we see that the fishery shows, shown here from 2014 through 2016, from the Northeast Ocean Data Portal, operates across the southern New England and mid-Atlantic continental shelf year-round, and the majority of the winter harvest coming from Hudson Canyon, Block Canyon, out on the edge of the continental shelf. The spring and summer inshore harvest occurs in the shallow waters along the south coasts of Long Island, Rhode Island, and Nantucket Sound, and also south of Martha's Vineyard and Nantucket Islands. Sea sampling of the longfin squid fishery is conducted by the NOAA Northeast Fisheries Science Center's Fisheries Observer Program, which is based out of Falmouth, Massachusetts. Each year, they're assigned a number of sea days to achieve within each fleet based on the prior bycatch rates of that fleet. The small mesh New England fleet, which includes the longfin squid fishery, was assigned 740 sea days in the past 12 months and 187 sea days in Q2 of last year. Mass DMF also conducts sea sampling. We work very closely with the Observer Program using their same protocols, and we can fill in any data gaps or sampling gaps in the fishery, and we sampled 3 trips in 2019. So knowing what data we had available, we discussed some of the concerns that we wanted to address with this report. Being a small mesh inshore fishery that directs on a foraged species, we were aware that there would be conservation concerns. We looked at the species being impacted, specifically those found to be overfished and overfishing occurring. The issue of leaving enough forage for local predators, which isn't just specific to the longfin squid fishery, is a common concern of stakeholders. Now, that being said, there are far more qualified biologists who are looking into this complex issue, who I would defer to. However, we can look at the literature that exists on predator-prey dynamics and make statements about how important longfin squid is to these predators. We were also able to look at the glut of stock assessment, landings, and sea sampling data to evaluate the impact on species that the fishery interacts with. Other concerns exist. Is the inshore fishery impacting future recruitment through interaction with egg mops? Are discards of legal-sized and marketable fish for any reason avoidable? And how can DMF address these issues? So, digging into the report itself, we first looked at how the fishery exists and occurs. Through the Massachusetts marine regulations, there exists a small mesh trawl exempted area that you see here in light blue in state waters. Small mesh trawl squid fishery exemption, which allows small mesh mobile gear to be used in this blue area, and a series of about 6 mobile gear closures that you see in these hashed or colored areas inside the small mesh exempted area. So the fishery also occurs via regulation April 23rd through June 9th and can be extended by the director. Vessels must be no longer than 72 feet in length. They must possess a coastal access permit with a squid trawl endorsement. And most vessels are fishing with trawl, but there's also fish weirs and rod and reel hand lines. Vessels fishing with a trawl must be fishing with a cod end mesh size no smaller than 1 7/8 inches, and net rollers no larger than 12 inches in diameter. So this paints a picture of trawls, fish weirs, and squid jigging. In the past couple decades, the landings from fish weirs have dropped precipitously, while jig landings have increased over recent years. But this gives us a fishery that's primarily prosecuted by bottom trawl, fish weirs, and squid jig vessels, and individuals as well. We couldn't simply include all data from every trip that landed at 1 pound of longfin squid, so we looked for a rule or a cutoff. Luckily, the Mid-Atlantic Fishery Management Council had conducted a similar analysis during development of their Amendment 20. For this analysis, they used a 40% cutoff, so all trips where 40% or more of the landings by weight were longfin squid. They found that 91% of all longfin squid was captured in those landings, and that was 2014 through 2016 data. When we applied that 40% rule to our 2013 through 17 time series of data, of landings data, we found that we kept 9 out of 10 trips and also over 99% of longfin squid. So we applied that rule to our data. We also pulled all the landings from Federal Statistical Area 538, which includes Vineyard Sound, Nantucket Sound, and Buzzards Bay, and state reporting areas 10, 13, and 12, which is south of the islands and state waters. However, when it came to describing landings from state waters south of the islands for federal reporters, we found a data mismatch where stat area 537, which extends the entire continental shelf, we could not tell which of these landings were from inside state waters. That somewhat hindered our future analysis. Now, that said, we were able to compile a large data set on squid landings and squid value. This data set tells us a story of coastwide historical landings and value. We see here on the left 20 years of annual landings from all states, with Massachusetts in green. You can see that Rhode Island in purple and New York and New Jersey in blue and red make up the majority of landings. We also see here on the right annual landings value with an annual average of $20 to $30 million, and annual average price that shows a solid increase this blue line here, in the past decade. Looking more locally, we see landings in Massachusetts from all areas and months exceeding 1 million pounds in a couple of years. And 2016 was a large year that exceeded 3 million pounds. And on the right side, we narrow it down to landings from within Nantucket Sound, and each year over the past 5 years where data was available, so 2013 through 2017. We see that 2013 was a very poor year for squid catches, and we'll continue to see that through the data. And that Rhode Island, the landings in red here, contribute a significant portion of local harvest. Those are landings, once again, in Rhode Island ports. And looking at the value of these landings, we see that average annual price per pound of longfin squid during the Massachusetts squid trawl fishery shows that trips landing in Massachusetts are receiving a very competitive price for their product. In fact, we actually see that Massachusetts prices exceed Rhode Island prices in most years. Broken down by month, over on the right here, we see that Massachusetts and Rhode Island prices tend to drop over the course of the season, whether it be because of market glut or reduced size of product. It's an interesting trend that we see each year. And then when we look at other species that are sold on these squid trips, we find that scup, butterfish, and fluke are also popular kept species. Bluefish, mackerel, and horseshoe crab are also caught and retained. And black sea bass stands out as well because of its recreational importance. So now, knowing what is being landed, we looked at who is doing the landing. To do so, we first looked at the number of unique participants and grouped them by vessel size. Small vessels were vessels 45 feet and less. Medium vessels were 46 to 59 feet in length, and large vessels were 60 feet and longer. We see in the top left here that in each year, there are more small vessels in blue than medium or large size vessels. These small vessels conducted far more trips, in the top right here in blue, number of trips, than the medium or large size vessels. Pounds landed, however, the large vessels accounted for more weight in landings than the medium or small vessels. That leads us to a hypothesis that large vessels tend to be trip boats, whereas small vessels tend to be day boats. We also had a hunch that there might be a state of landing effect to this as well. So to confirm this, we looked at trip duration in number of days from both vessel trip reports, which is all trips, and observer data, which is a subset of trips. Broken down by year and by state, we found very consistently that Massachusetts boats in blue and green here averaged about 1 to 2 days per trip, closer to 1 day per trip. And Rhode Island boats in the red and the purple conducted about 4 to 5 day trips. So this helped round out our picture of the fleet, and it was a convenient use of the available observer data. Speaking of observer data, we mentioned the Northeast Fisheries Observer Program and Massachusetts DMF's sea sampling program, Fisheries Dependent Investigations. We sample squid using the same protocols. A tow comes on board. We attempt to get actual weights on all the discards. If that's not possible, and there's a high volume catch, we will subsample using fish baskets and scales and calculations to expand up the bycatch to the entire tow. And we also collect lengths on discards primarily, but also kept species. And we take age structures, scales, otoliths for stock assessment purposes. We had to decide what trips we were going to collect the data from. So to do that, we chose trips that occurred, or hauls that occurred from April 23rd to the date that the fisheries closed in 2013 through 2017. We selected hauls where longfin squid was the stated target species of the captain, and where any haul that began in Vineyard Sound, Nantucket Sound, or within 12 nautical miles south of Martha's Vineyard or Nantucket Islands. This resulted in an overwhelming amount of data, over 1,400 hauls, 199 unique trips, 1.23 million pounds, and over 13,000 lengths collected on individual specimens. We then had to partition that data into, in order to look for trends in the fishery. And we chose to split that data into 4 areas, 2 of which were in state waters and 2 of which were in federal waters. We label these areas Vin-Nan Sound for Vineyard Nantucket Sound in the light blue here, 0 to 3 nautical miles south in the darker blue. Those are in state waters. And in federal waters, we had 3 to 6 nautical miles south in yellow and 6 to 12 nautical miles south in orange. And we'll use these naming conventions throughout when we're discussing the data that we collected or that we analyzed. The sea sampling data assigned by area gives us 169 trips and over almost 1,200 hauls in Vin-Nan Sound alone. Obviously, there's fewer trips conducted in other areas. Some trips were conducted in multiple areas, hence the decimals. And of note here is the 6 to 12 nautical mile south area. The trips during the fishery, there was fewer than 4 trips, 14 hauls. So it's a little concerning. And we do have some data confidentiality issues and issues with making strong statements with only 14 hauls. So we note that when it exists. The trip coverage rates were able to be calculated for Vineyard Nantucket Sound area and annually averaged between 7 and 14%. And overall, for the 5 years, averaged about 10%, which is respectable. So plotting the observed hauls by area, we saw some really interesting effort patterns and could actually see the hauls that fishermen talk about when they discuss, where they're going fishing or talking to other fishermen. In Nantucket Sound here, in the top left corner, we see a lot of effort in the main channel, some in the Tuckernuck Shoal channel, the Horseshoe Shoal, but also up in the Collier Ledge and Saconaset Shoal areas. South of the islands, we see a distinct east-west tow, both south of Nantucket and Martha's Vineyard. And we see the same thing in federal waters, an east to west tow. These are haul begin locations. So the haul could begin on either end, and this looks like fishermen towing back and forth, and 6 to 12 nautical miles south as well. So then digging into the sea sampling data and the catches that were observed, we first look at the overall kept versus discarded catch by year. And we have kept here in blue, discarded in red. And we see this fishery has an overall discard ratio for the 5-year period of 28.6%. By area, the discard rate is fairly consistent across years, with 6 to 12 nautical mile south area having the highest discard rate. By year, we see greater variability, with 2013 and 17 showing the highest discard rates, and 2015 showing a very low discard rate. We also looked at the reason for discarding, which is recorded by the observer as dictated to them by the captain. There were 3 major categories for discarding. There's market-related reasons, regulatory reasons, and other reasons. And it's hard to see on this slide here, but the market-related reasons were primarily reason not specified or too small. Regulatory reasons were primarily too small to keep because of regulations, no permit or quota filled. Other discards consisted of debris, empty shells, or poor quality. We then started building catch and bycatch data tables with the over 100 species that we encountered. And it was a lot of data. These tables are just examples of what we looked at in order to find the species of importance that we wanted to look into further. We first looked at finfish, shellfish, and other. We binned them by these categories. And first found that seaweed, which is part of other species and debris, made up over 8% of all catch. The seaweed bycatch is a nuisance. It clogs nets and the meshes in the nets, and it can be time consuming to pick through, and sometimes it can actually end a fishing trip. It was over 8% of the catch, as I mentioned, and we removed it from further analysis to get more at what was actually being caught. We see that scup is the #1 finfish catch. Black sea bass, butterfish, and summer flounder has a high price and is desirable for a catch. So we included that as well. And of course, longfin squid is the #1 catch overall, and it is a shellfish. So selecting these 5 species because of their importance to commercial fisheries and recreational fisheries. We labeled them the Big 5 and selected them for further detailed analysis. So for each of these species, we first developed a catch per unit effort, which is a standardized statistic of catch per hour, in this case, pounds per hour, so that we could see the kept and discarded catches by area and by year for each of these species. We looked at the reason for discarding and the kept and discarded lengths that the observers collected on these species. With these figures, we're often able to interpret the data and see if there's anything biologically or management related that explains these trends. First, we start with Longfin Squid, and we look at all the metrics at once. Looking at the catch per unit effort by area, we immediately see that from Vinland Sound, 0 to 3 nautical miles south, into federal waters, 3 to 6 and 6 to 12 nautical miles south, the catch rates increase. And this could be a function of larger vessels or time of year, but that's just one trend that we started off with. We also see that the boom 2016 year had the highest catch rates, over 600 pounds per hour of towing, whereas 2013 had the lowest, less than 100. Director McKiernan suggested we look at squid CPUE by time of season, and we see that in all 4 areas, the catch per hour increases as we move to the June 9th end date and weeks 23, 24, and 25 into the extension years data here. And that's interesting to see. It suggests that the fishery is actually becoming more efficient at the time of the closure. And squid were also discarded on 15% of the hauls. That's a really low number that we were surprised by. They were discarded for small size and poor quality reasons. It made up over 80% of the reasons for discarding. And we see the lengths of the kept squid in blue here and the discarded squid in red. And the cutoff really between what's kept and what's discarded. Most discarded squid are 12 centimeters or about 5 inches and smaller. Onto the catch per unit efforts of the remaining species of importance. We see discard pounds per hour in red, which we didn't really see with squid, and kept in blue here. Starting with scup, we see more discarding in the Vinland Sound area than any other areas, and far more discards in 2016 and 2017. We quickly looked into why and found that this is basically due to a monstrous 2015 year class of scup that was the largest ever in the time series for the stock assessments. So one reason that we found the data was, it's supported by stock assessment data. Butterfish catches and discards by area showed similar trends, more discards in federal waters here, with far more discards in 2016 and 2017 due to a large year class as well. Summer flounder catch rates are stable across all areas, kept catch rates, excuse me, but discard rates go up as you go into federal waters and further offshore. Black sea bass discards by area may have a regulatory aspect, as vessels were not allowed to, during this time period, land black sea bass in Massachusetts from this fishery, but they were in Rhode Island. And we see annual spikes in black sea bass discards that coincide with 2 large year classes as well. Looking at the reason for discarding for these primary 4 species, we see that the scup are discarded because either they're too small or the regulations and market-based reasons, or their trip quota is filled. Butterfish were discarded mainly because they're too small for a market, or there was no market for them at all. Fluke were discarded because the trip quota was filled, no permit, or the vessel was keeping only a certain size of fluke or waiting till the trip end to keep their fluke. Black sea bass were discarded, as I mentioned, because they couldn't be retained if you were landing in Massachusetts. It's recorded here as prohibition on retention or no quota in the area. And by looking at all the recorded lengths of the bycatch, we can confirm some of these reasons for discarding. For example, scup here with a minimum retention length of 9 inches shows that there were some legal size keeper scup that were discarded, and that was once again primarily due to market reasons. Butterfish looks like it's up to the fisherman or the dealer on the preference of size, what they would like to keep. Summer flounder shows a size selection for best price, as the discard data also suggested. And black sea bass showed that only the largest fish were being kept by some of the boats, primarily Rhode Island boats. And some other notable catches worth presenting are seen here in this table. These species are of interest due to their interstate management plans or because they are species of interest to various stakeholders. For example, we have alewife, blueback herring, which are river herring, and American shad. We also have striped bass catch, which is 1,479 pounds out of the 1.23 million pounds overall catch. And you can see here that striped bass occurred in less than 6% of hauls in Vinland Sound, and a little bit more, up to 20% in offshore areas here. The observers, as part of their protocols, collect data on individual animals, it's called. These interactions happened on 6 out of the 199 trips. 85% of the time these animals were released alive, and these animals included torpedo rays, basking sharks, sand tiger, mola mola. Incidental takes, so marine mammals and seabirds and turtles, occurred on 5 out of the 1,405 hauls. Those species were gray seal, Rizzo's dolphin, and a dolphin NK, which could not be identified. So this data analysis reveals trends that let us look at stock assessment documents and scientific literature to explain our findings. First, we tried to address overfishing concerns. Looking at the biology of longfin squid, we find that they're biologically resilient. As we mentioned before, they're fast growing. They spawn year round, forming micro cohorts. They're sexually mature in 5 months, and the squid that spawn inshore and hatch inshore create the biomass for the offshore fishery, and vice versa. The squid, the juveniles that are spawned offshore, migrate inshore in the spring and the summer and create the biomass that is fished on in the spring fishery. In terms of bycatch, species that are overfished and overfishing is occurring do exist in the data, but not in very large amounts. The most prominent is Atlantic mackerel, which was a little less than 1% of the overall catch. But Atlantic mackerel currently has a rebuilding plan and has recovered to the point where quotas have nearly doubled on the species. Winter flounder also has a rebuilding plan and doesn't fully utilize its annual quotas at this point. Cod and red hake also have overfishing currently occurring, but their catches are very low in this fishery. As far as removal of forage, the million-dollar question, is there enough? Once again, a little bit outside the scope of this document, but we wanted to bring it up. We can, however, look at the specific predators that we do know of particular significance and look at their diets from literature. For example, striped bass, Gary Nelson from MassDMF study found that in 1997 to 2000, striped bass caught in Nantucket Sound preyed mostly on crustaceans, 50% by weight, which was primarily lady crabs, and then fishes made up 40% of the catch: sand lance, sea robin, menhaden scup. Squids, or as it was called, unidentified cephalopods, made up 3.3% of the catch. So we know that while striped bass do eat squid, obviously in Nantucket Sound, they have a variable diet as dictated by this literature. Looking at the impact of bycatch, we first look at species of recreational importance to address stakeholder concerns. Using the striped bass bycatch rate that we found in our data, for every 1 million pounds of squid caught in Nantucket Sound, we get roughly 1,000 to 3,000 pounds of striped bass, which is relatively small in comparison to the commercial and recreational striped bass fisheries of Massachusetts. It's also worth noting how hardy the striped bass are, when they are brought on board in these short duration shallow water tows. Scup, making up 14.3% of the catch, has underutilized its commercial quota and historically, and the 2017 stock assessment found that the spawning stock biomass for scup was over 2 times the biological target. Black sea bass recreational harvest and summer flounder recreational harvest are primarily taken, eclipse or commercial harvest each year. Disruption of squid egg mops remains a valid stakeholder concern for both recreational and commercial fishermen. While no local directed studies have looked at the degree that egg viability is impacted by disruption, there is evidence that displacement could lead to early hatching and thus incomplete yolk sac absorption. These mops, as they're called, hatch in 12 to 34 days in Nantucket Sound when they're undisturbed. It is worth noting that the inshore fishery has numerous gear closure, untowable areas, and presence of fixed gear areas, which may provide some level of refuge to egg mops because the squid fishery cannot operate in these areas. Having personally handled squid trawl caught mops, they seem pretty robust, and we know that the inshore recruitment from these mops may only directly impact the offshore adult biomass in a subsequent season, and that could buffer any local impact. But this topic we flagged as one for potential future consideration, and regional scientists have expressed a desire to look into this. We look at discard rates relative to other regional fisheries, and the NOAA National Bycatch Report is a good place to find those. This figure here, which is impossible to see for you guys, but it's in the appendix of the document. Each row represents a different gear type and fishery, fleet in 2015, with low bycatch on the bottom here and high bycatch on the top. Low bycatch down here is almost negligible. That's the New England midwater trawl fishery, I believe. And the top here is the Mid-Atlantic scallop trawl and Mid-Atlantic large mesh otter trawl. We find that the New England and Mid-Atlantic small mesh bottom trawl fleets, which include the squid fishery, are basically in the middle of the pack at a 25 to 30% bycatch or discard rate, excuse me. And that corresponds with the data that we've found as well. And finally, the economic impact of the longfin squid fishery is something we tried to detail. Now, I'm no economist, but I did my best. And right as the report was being published, a study from some economists came out, and that would have been very useful, but it did make it into the presentation here. They found that coastwide and an average year from 2013 to 17, the same time series that we used, the longfin squid fishery created over 2,500 full-time jobs, $20 to $30 million in revenue to the vessels, almost $100 million in income, and over $240 million in economic output across all sectors. And that was a really interesting report because I had tried to do a similar thing for Massachusetts, which was very difficult. I'll just put it like that. What we did look at was the economic benefit and importance of the longfin squid fishery in Massachusetts. We aggregated all sales from all vessels landing an average of 10,000 pounds or more squid in 3 to 5 years from 2013 to 17. And that we labeled those 23 vessels our Massachusetts squid fleet. So the sale of these longfin squid vessels, of the sale of longfin squid by these vessels made up 22.7% of their overall annual revenue. That was followed by fluke, scallops, and monkfish sales. Groundfish as a suite made up 33.8% of their annual revenue, and that was made up of dabs, cod, blackbacks, haddock, and other groundfish. So in general, what we see is that the spring longfin squid fishery supplements the groundfish fishery, which continues to rebuild its stocks and necessitates owning or leasing quota to go catch fish. This profile represents landings from multiple gear types and suggests that vessels transit from other areas to pursue longfin squid out of Massachusetts ports, also bringing with them a need for fuel, net mending, groceries, and other infrastructure. This analysis paints a picture of the 48 to 55-day longfin squid season, constituting an important part of these vessels' annual business plans. And finally, an evaluation of the monitoring and management of the local longfin squid fishery. We can say that the sea sampling remains robust, and the sea day allocation process would increase monitoring if the overall discards in the fishery also increased. The observer program and both DMF have good rapport with these fishermen, and both projects go to great lengths to collect high quality data and make it available to managers quickly. Quota monitoring has built-in backstops. Trimester 2, which accounts for the inshore harvest, is only 17% of the annual quota. Carryovers are limited, and the paybacks, if there are any overages, come from within the same year. Federal management has shown a desire to hold the fishery accountable with butterfish bycatch caps as an example. The Mid-Atlantic Fisheries Management Council Advisory Panel for squid, mackerel, butterfish has many members from the recreational, party, charter, commercial, and NGO sectors. And in closing, state management remains robust and well-informed. Our sea sampling program can allocate sampling resources where needed, and our outstanding relationship with the Federal Observer Program allows us to acquire and summarize in-season squid data collected in the previous week for the director in order to inform season extensions beyond June 9th if warranted. And finally, the director and the Marine Fisheries Advisory Commission have proven flexible and responsive to stakeholder concerns. And with that, I'd like to thank the following people and take any questions.